Erica here with PrepScholar GRE. Here today to teach you how to beat GRE data interpretation questions. If you like this video, subscribe for more great content and check us out at gre.prepscholar.com to learn more about what PrepScholar GRE can do for you. So the purpose of data interpretation questions is right there in the name. These questions require you, the test taker, to interpret data presented in various formats, specifically tables, graphs, and other visual presentations. Now, there are going to be 3 data interpretation questions in each quant section on the test. Since there are 2 scored quant sections on any given exam, this gives us 6 scored data interpretation questions on the exam. Out of 40 quant questions, that's not insignificant. That's about 15% of all quant questions. So this means that mastering our data interpretation strategy is going to be critical to our GRE score. Now, all 3 data interpretation questions in one section are presented together. So this makes sense because they all go with one set of data. This set of data may include multiple tables, graphs, diagrams, etc., or just one. We can think of these a lot like multi-question reading comprehension passages, a bunch of information given to us up top that's used to answer a series of questions. The questions in data interpretation sets can come in multiple types. They can be multiple choice select one, multiple choice select one or more, or numeric entry. The one thing they can't be is quantitative comparison. Now, okay, how can we approach these question sets for the highest likelihood of success? Since these questions are so much like multi-question reading comprehension passages, we want to approach them in a very similar way, by skimming the data for key ideas. So, what information is being presented? How is it being presented? What are the main things we see in the data? And what's likely to mess us up down the line? We can find this information by looking at specific things in our data. So the first thing we want to take note of is the title of our graph, table, what have you. The title typically does a good job presenting what information is contained in the diagram. Now the second thing we want to take note of are any subtitles. So in the case of graphs, these are going to be our axis titles. In the case of tables, these are our row and column titles. Again, this gives us a good overview of what's in the data, but it also gives us a window into how to read the data. So a key thing to note here is going to be scale or units. If the data is in thousands of dollars, we don't want to get confused thinking it's simply dollars later. If our data is a percent, we don't want to get confused thinking it's a value later. So the third thing we want to look at are our labels, legends, or other notes. Like the axis titles, scales, and units, these are going to help us read our data accurately. Now, there's no need to memorize the information here. Just take stock of it so we remember to incorporate it later. All right, fourth, we're going to look for any general trends. An increase, decrease, consistency, differences between groups, etc. Now, we're not going for detail here. I don't actually care how much profit Company B made in 2007. What I care about is whether or not the profit Company B made increased from 2007 to 2010, whether it increased consistently, and whether or not it was consistently higher or lower than the profit of Company A. Finally, we want to make sure we can quickly summarize our data using all 4 things we've already looked at. All right, now that we have a good idea of what data we have access to and what we can learn from it, we can move on to the questions. The first thing we want to ask about a given question is what do we need to look at to answer the question? For the most part, we're not going to need all of the information in the data to answer a single question. Often we'll only need a single row, column, or even just a single data point. We want to be sure that we know what we're looking at as well as what we aren't. So if this were a paper test, we'd go ahead and lightly circle the information we are using or cross off everything we aren't. However, since most GRE exams are computer-based, we'll go ahead and mentally make a note of what we care about or copy the relevant information onto our scratch paper where we can make better use of it. All right, then as we proceed to answer the question, we're going to look out for common traps. We've already touched on our first trap a bit, which is misreading the data. Now, this can happen because we missed some key piece of information. So this could be not recognizing that we have a percent instead of a value, or hundreds of students instead of single students. However, we can also misread the data even if we know exactly what we're looking at. This is especially easy to do on questions that deal with graphs, where we need to estimate approximately where our different points fall. All right, our second trap is going to be answering the wrong question. So oftentimes we answer a question that's a good question to ask about the data, but not the question that's being asked. For instance, when we're asked for some sort of relative value, so a percent, a ratio, a fraction, etc., it's really easy to mistake what the denominator is. Is this fraction out of the total, or is it of a subtotal? Okay, which subtotal? Similarly, when a question is asking for a certain data point, it's very easy to mistake one element of that data point. For instance, when we have a graph with multiple lines or bars, it's very easy to answer the question for the wrong line or bar. When we have a table, it's easy to answer the question for the right row, but the wrong column, and so on. This is especially dangerous because the test makers want you to answer the wrong question, so they'll often include answers to these other good questions in the answer choices. So because of this, we need to be careful both in reading the question and confirming our answer. So these traps are going to be easiest to avoid if we spend time up top being sure we know what the question is actually asking. So putting the question in your own words, translating into math, etc. are going to be good steps for avoiding these traps. Similarly, taking time to try to predict an answer is often a good call. We're less likely to fall for answer traps if we aren't using them to make our choices. All right, finally, it's important to recognize that we can skip around within our data set as well as within the section as a whole. If a problem is giving you grief, move on. Often after spending time with other problems connected to the data set, you'll be more likely to understand the data set as a whole and the problem you're currently working on. All right, now that we've worked out our data interpretation process, let's try working through a couple of real GRE data interpretation problems. All right, if you'd like to give this problem a shot on your own, feel free to pause the video and do so because we're going to jump right in. So as we discussed, the first thing that we're going to do is completely ignore the question and look exclusively at the data set. So the first thing that we're going to look at is the title. Now here that's 3 types of electronic units in stock and sold by stores R, S, and T last month. So this is what we're going to be looking for in the data. That's what it's going to tell us. Now, what we notice is that this title refers to 2 different pieces of data. So on the left, we have a table, and on the right, we have a graph. So we're going to just know going into it that each piece of data is not going to be complete. There's going to be just a subset of information in each one. So we'll go ahead and start with the table. Now the title here is number of units in stock. Okay, so remember going back to that title, how it was 3 types of electronic units in stock and sold by. Here, we only have this in stock information. We don't know anything about sold by. So we're going to pay attention to that because this is likely something that they're going to use to trip us up later. Okay, so let's move on to the subtitles, which in this case are our column and row titles. So looking down the side, we have the store, R, S, and T. And then along the top, we have the different types of units. So CD players, GPSs, and television sets. So those are those 3 types of electronic units that the title was talking about. Now, looking at this data, we can use these row and column titles to figure out how many of each type of unit each store has in stock. We still don't know anything about how much they've sold. So for instance, we can find out that store T has 50 television sets in stock. Don't know how many of those they sold. Now, looking for any sort of trends that we might be able to see, I'm noticing that CD players, they're more in stock than any of these other ones. But other than that, there's nothing really speaking to me here, no strong trends. So we'll go ahead and move on to the graph. Now, the graph's title is number of units sold as a percent of number of units in stock. Now that's interesting. So remember that we had units in stock and sold by in the title. This is the sold by part. However, they don't give us the actual number. They give us the number of units sold as a percent of the number of units in stock, exactly what they tell us in this first table. So these actually work together. Interesting. We'll come back to this a little bit later. So we'll go ahead and look at our subtitles, which in this case are our axis titles. So on the x-axis, we have the stores, R, S, and T. And on the y-axis, we have that percent of the number of units in stock that was mentioned in that title. Now, really quickly, we're just going to note this is a percent. This is not a real number. We know that this is a really common trap on these data interpretation problems, so we're just going to pay really close attention to that. Leave a little flag on that in our mind so we don't forget about it. Now we also notice that we have a legend here that tells us what the different colors here mean, and these different colors represent those different types of electronic units. So that kind of medium light gray is CD players, the white is GPSs, and that darker gray is television sets. So we can use that to find out what percent of the number of units in stock for each different type of unit were sold by each of those stores. So going with television sets at T, we find that they sold 90% of the units in stock. Okay, looking for any trends, nothing particularly interesting. I'm noticing that they each sell a higher percent of a different electronic device. Yeah, nothing really speaks to me here. So I'm just gonna kind of leave it as is and search for the data later. All right. Bringing it all together for kind of a summary. We already figured out that these can work together, so let's try that really quickly. So we already figured out that there are 50 television sets in stock at T, and that 90% of the television sets in stock are sold. So that means putting that together, 90% of 50 is 45, which means that 45 TVs were sold at store T last month. Cool, awesome. We know how to interpret this data. Now we can go ahead and move on to the question. So we'll start by just giving it a quick read through. So each of the CD players sold by store S last month was sold at the price of $119.95 plus a 7% sales tax. Approximately what was the total revenue, including sales tax, for the CD players sold by store S last month? Now, if we try to take all of that in at once, we're going to go, whoo, that's way too much. There's way too much stuff in there to do all at once, and we'll probably make mistakes. So we're going to try to break this up a little smaller. But one thing that we probably notice right off the bat is that we're only talking about CD players sold by store S throughout this whole question. So that means that we're only looking at a very small amount of data. In this table, we are literally only looking at that 90. Everything else is store R, store T, it's GPSs, it's television sets. We don't care. So we can actually pretend that this table looks like that. And we can copy this information onto our paper so that we know exactly what we're looking at. For our graph, that's the only bar we care about. Everything else doesn't matter. So again, we can pretend that it doesn't exist. So we know that there are 90 CD players at store S, and that 80% of those CD players are sold. Cool. So let's go ahead and kind of break this down piece by piece. So just looking at the first part of this first sentence, each of the CD players sold by store S last month. Okay, so we're looking at the CD players sold by store S, which means that this 90 units in stock is not super helpful. So let's go ahead and do what we did before for TVs at T to figure out how many CD players were sold by store S. So to find that out, we're going to find 80% of 90. So we can do 90 times 80 over 100. Now, at this point, a lot of folks are going to reach for their calculator and go 90 times 0.8 and figure out what that is. However, this can be kind of time consuming. That calculator is unwieldy and it takes a lot of time to get it out and punch all the numbers in, blah, blah, blah. So what we can actually do is just do some pretty easy math. If we go ahead and cancel all these zeros, so this 0 goes away, that 0 goes away, this 0 goes away, that 0 goes away, all we have is 9 times 8. Which is 72. That's a mental math fact that we all know. So what we know is that 72 CDs were sold by store S. One quick tip here, using fractions for dealing with percents is often easier for quick math than decimals are. So know that. All right, we'll go ahead and move on to the second part of this sentence. So we know that each of those CD players was sold at the price of $119.95 plus a 7% sales tax. Okay, cool. So it wasn't just this price. There was also a 7% sales tax on top. So the final price was 107% of that original price. Let's go ahead and find what that is. So we'll go ahead and use that same method we did before, where we have the original $119.95 times 107 over 100. So finding 107% of that cost. Now, this one we're probably even more tempted to do with our calculator because there is no way to make this math a little easier. No zeros cancel. These are ugly, ugly numbers. And you know what? That's okay. If you go ahead and do this with your calculator, we would get $128.35, which makes sense. However, calculators in general can be time consuming, and we can do this with estimation. Now, there's a really good clue that estimation is a great choice for us here, and that's that word approximately in the last sentence, which we should have caught on to right away. This tells us that we can be a little bit fuzzy with our numbers. We don't have to be exact. So we also notice that this first number, 119.95, okay, that's really close to 120. Right? So we're really close to an easy number already, which leads us to think maybe they want us to estimate. So let's estimate this for 120, and let's say 107, 7% sales tax. Let's just go with 10% and know that it's going to be a little bit high. So instead, we can estimate 120 times 110 over 100, or basically 120 plus 10% of 120. That's going to be 12. So 120 plus 12, which gives us 132. We already know that's a little high. Let's bring that down to 130 just to make it a nicer number. And just know that this is going to be maybe a little bit higher than the actual number we would get, which obviously we can see because we calculated it. It's 128.35, which is actually pretty close. Okay, so now we know the number of CDs sold by us and the price of each of those CDs. What are we trying to find here? So we're trying to find the approximate total revenue, including that sales tax, for the CD players sold by Store S last month. Okay, so how do we find revenue? Well, revenue is the amount of money brought in by sales. So here we know that we sold 72 CDs. Each of those CDs brought in about $130. So to find that total revenue, we're going to multiply the number of CDs sold times the price of each of those CDs. All right, now if we want to go ahead and use those numbers that we already found, if we use the calculator, we can continue down that path and multiply 72 by 128.35 and get our answer, which is $9,241.2 or $9,241.20, which is really, really close to one of our answers. We can go ahead and pick it. However, if we want to continue down that estimation path, we can. So in that case, we would do 72 times that 130, which looking at that, I don't know, 72, kind of ugly. So let's break this down and make this a little bit easier, kind of like we did with CDs sold. So 72 is the same thing as 70 plus 2. So let's consider this as two separate problems. 70 times 130 plus 2 times 130. Now this is a little easier. 7 times 13 gives us 91. Throw those two zeros on, gives us 9,100. 2 times 130 gives us 260. Add those together, we get 9,360. Now, looking at our answer choices, we see that that's really, really close to B. And we remember, we thought that 130 might be a little bit too high. So this actually aligns perfectly with that logic we were going for, and we can go ahead and safely pick B as our answer without using the calculator once. All right, now let's go ahead and look at some of these wrong answers to see how might we have been tripped up if we weren't really, really careful. All right, so D is kind of a bummer of an answer choice. So this answer is what we would have got if we'd gone, okay, instead of the number of units sold, we did the number of units in stock. Maybe we missed this part of the title. And then we multiplied it by the base price without considering the sales tax. So double whammy on the mistakes, kind of a bummer, but really, really common. For E, all right, this time we got the 7% sales tax. Nice. But we still missed sold. So we picked that 90 for in stock. Now maybe they even read sold the first time they did it, but then lost that information later. So we want to be really, really careful to make sure that we're writing things down as we go and really paying attention and setting ourselves up for success by noting where we might make a mistake earlier on in the process. All right, C is an interesting one. We got that sales tax again, but this time, instead of doing the number of units sold, they did the percent of units sold. They saw this sold up here and went, done. That's my number, it's 80. Instead of thinking, oh no, this is a percent, it's not a real number, I can't use it by itself, I need to combine it with the information about the number of units in stock. So bummer of an answer choice. And then A is kind of an interesting one. This one, we found 72, so we found the 80% of those 90 units in stock, and then we forgot to add that sales tax. So here we interpreted our data beautifully, did kind of the hard part, but we just forgot to add the sales tax, even though they mention it twice in the question. So this is also a mistake that you can make. We want to make sure that we're paying attention both to the data and to the question itself, because it's really easy to miss information there. So what we notice here is that these answer choices are not mistakes. They're not random. They're here to confuse you. They're here to trick you, and they're here to get you and make you think that you're right if you made a small and very common mistake. So being really careful to pay attention to what we're looking at and what we're being asked for on these data interpretation questions is absolutely crucial. All right, same data set, different problem. We're not going to do this one together though. So go ahead and pause the video and give this one a shot on your own using the techniques that we looked at in the other problem. Go ahead and leave your answer in the comments, in addition to what you think some of the traps in this problem might be. Where do they want you to mess up? So go ahead and leave those comments below and see what everyone else thinks. Thanks again for watching, and feel free to check us out at gre.prepscholar.com for more great GRE content. See you next time.